Have you ever wondered how an automatic watch works? What are the mechanisms inside these timepieces that help us tell the time? Well, fine watchmaking has the answer. Before we can start talking about the components that make up an automatic watch, we should first discuss some brief history. Watches in general evolved from portable spring-driven clocks which first appeared in Europe the 15th century. The first timepieces to be worn were made in the German cities of Nuremberg and Augsburg the 16th century, and they varied in sizes between clocks and watches. German clockmaker Peter Henlein is often credited as the inventor of the watch. Now for the automatic watches, although many watchmakers claim that invention, the earliest credible evidence for a successful design is the watch made by the Swiss watchmaker Abraham Louis Perellet in late 1776 or early 1777. Now that we have a solid background, it's time to dive in the components of a self-winding watch. First off, we have the main plate and bridges. These are structural components of the movement. Every part that we will discuss is mounted on or between the main plate and bridges. Think of the main plate as the base floor of the watch and the bridges as support beams. The main plate and bridges hold everything in place. The main plate houses holes and recesses for jewels, which we will discuss later on, screws and pins. All of its components are engineered to perfection, ensuring timekeeping accuracy. Bridges. Bridges secure the rotating components and are screwed into the main plate and aligned with dowel pins to avoid misalignment. Now for the major components that generate the whole movement. First off, we have the rotor. The rotor is a semicircular metal weight that moves freely 360 degrees inside the watch and oscillates whenever the wearer moves their hand. This oscillation of the rotor winds another component of the watch, called the mainspring, by providing potential energy. The rotor is what makes the watch automatic. Now, the mainspring, which is powered by the oscillation of the rotor, is a long, thin and flat coiled spring inside a round metal barrel. When the mainspring is wound by the rotor, it stores potential energy. The mainspring then slowly unwinds and releases that potential energy into the rest of the watch, aka the train gear, powering the whole movement. A typical fully wound mainspring can power a watch for 40 to 80 plus hours. As an extra, the mainspring is often made of special alloys like Nivaflex for durability and resistance to deformation. At this point, you might be thinking, what's the so-called train gear? Well, the train gear is an entire system made from tiny interlocking gears. The purpose of the train gear is to transfer the potential energy stored in the mainspring to the rest of the watch's mechanism. Other purpose of this component is to reduce the high torque from the mainspring by making the movement smaller and more controlled. In summary, the train gear connects the wound mainspring to the timekeeping parts, which are the escapement and the hands. Which brings us to the fourth component, the escapement. You can think of the escapement as the gatekeeper of the watch. The escapement, as the name suggests, controls how energy is released from the mainspring. The escapement consists of two major components. First is the escape wheel. The escape wheel is a spiky gear that wants to spin freely, but it's held back by the pallet fork, a fork-like component that oscillates, locking and releasing the escape wheel. Each release of the pallet fork makes a tick sound. The escapement as a system, including both the escape wheel and the pallet fork, transforms the continuous energy provided by the mainspring into pulses that drive the timekeeping mechanism. Moving on to the fifth component, we have a beautiful connection of two pieces. The first one is the balance wheel. The balance wheel oscillates back and forth at a constant rate, usually 5 to 10 times per second, controlling the whole rhythm of the watch. The accuracy of the balance wheel's oscillations determines the bit rate, which defines how many times per second energy is released to the train gear. The other component is the hairspring. No, it doesn't have to do with any hair, instead it acts like a counter to the balance wheel, bringing it back to its center after each swing, ensuring the movement is consistent. The more vibrations go through these two components, the smoother the second hand movement and better precision. Component number 6. Dial train or motion works. This component is an assembly of gears that translates the regulated movement of the escapement and the balance wheel into motion of the hour, minute and second hands. It also connects the train gear, which as we said transfers energy, with the hands, which show time. The dial train consists of the center wheel, which is a wheel placed at the center of the movement and rotates every hour. It is directly responsible for driving the minute hand via another part, the cannon pinion. The cannon pinion is a hollow shaft fitted around the center wheel's arbor. The cannon pinion makes a full rotation every hour and carries the minute hand as well. Other element of the dial train is the hour wheel, which sits above the cannon pinion and rotates once every 12 hours. Lastly, we have some secondary gears, the minute wheel and the minute wheel pinion. Take some time to observe the sketch. So, in summary, we have the dial train, which consists of the center wheel, the cannon pinion and the hour wheel. Element number 7. The jewels. Jewels are tiny bearings made of synthetic ruby or sapphire. They are used to reduce friction and wear between the moving parts of the watch. They are placed between critical pivot points where the speed and pressure are higher, for example in areas like escape wheel pivots or balance wheel contact points. Oftentimes, oil is applied to the jewel hole or caps to reduce friction even more. The whole purpose of the jewels is to ensure the watch's movement remains accurate even over the course of many decades. The jewel count of a watch can vary from 17 all the way to 40 plus, depending on the engineering. At this point, we have covered the whole interior of an automatic watch, and we can start discussing some external visible components. Crown and winding mechanism. The crown is an external knob used for three main functions. 1. To wind the watch manually. 2. To set the date. 3. To set the time. The crown is connected to the gear train via a stem, which engages a lever into different positions with each pull we make. Position 0 of the lever. The crown is pushed in. The watch winds on its own. Position 1 of the lever. Pulled once. When we pull the crown one time, we can set the date. Position 2 of the lever. Pulled twice. When we pull the crown two times, we can set the time. These adjustments are regulated by a clutch mechanism, which ensures that rotating the crown in different directions does different things. Now for the last 100% visible components of the watch. The hands and dial. The hands are what we use to read and tell the time. They are press fit onto their respective shafts. The hour hand is on the hour shaft. The minute hand is on the cannon pinion. The second hand is on some secondary shafts within the dial train. The dial is the printed or decorated face of the watch that gives structure and aesthetics to the time display. It often includes printed markers, subdials, or apertures. That's it for the automatic watches. I hope you picked up something new. For more videos and to stay tuned, don't forget to subscribe and always remember, knowledge is power.